This one is 3.15. Here we need to calculate the internal forces and moments at section 1 and section 2. So the geometry of the structure is that this angle is 60 degree here. These dimensions are A and A. So assuming that these two are also same, we can see that these angles are going to be all 60 degrees here. In terms of reactions, there will be a support coming from here, and since it's a symmetric structure, both of these are going to be P by 2 and P by 2. So they'll equally share the load. So now let's go to this section 1. So if I want to analyze what's happening at section 1, I can isolate this part of the body and look at the forces. So in that process of isolating this body from here, you'll see that this section, which is right here, will also be opened up. So if I put these names here, A, B, C, D and E, so this member BD is also being opened up there. So now if I draw the forces, there will be a reaction P by 2 here, there will be this force FBD coming on it, and at this point when we cut it open, this is a negative face that opens up, so we'll have an axial force going this way. Let's mark this as F1. There will be a shear force going downwards, so let's mark V1, and there's a bending moment here, so let's call this one as MB1 there. Now for taking components of these forces in one common direction, we can follow the coordinate system, which is X going this side and Y going in that manner. So that way, if you notice, this force P can be divided into two components. So this angle is also going to be 60 here. So this component right here is going to be your P cos 60, and this one right here is your P sin 60 degrees. Now FBD force that you see here, FBD will have your FBD going in this direction will have cos component, and in this direction you will have sin component there. So let's start writing the equations along the axial direction. Axial direction, we have force F1, then we have FBD cos 60 degrees, which is this one right here. If I extend FBD in that direction, and your P by 2 force here, my mistake, these are P by 2. So P by 2 is going to have P by 2 sin 60 in the x direction. So plus P by 2 sin 60 equals to 0. Similarly, if I go in the y direction, we have V1 going there plus FBD sin 60 in the same sense minus this P by 2 cos 60 equals to 0. Now for moment, I can take moments about this point. So your MB1 will balance your moment coming from this force P by 2 there. So P by 2, and the distance in this case will be this right here, which is A by 2. So you can notice here that to solve for this, we need the value of FBD, right? So for FBD, we can again analyze this part of the structure and isolate this. In terms of forces, we have this force coming here as an axial force, so this is going to be FBD. This force right here is P by 2. We have this P appearing here, and because of this member BC right here, there may be an unknown force which is acting in this direction right here. So in this case, if I take moments about this top point right here, I can write a moment equation, which is FBD times this vertical distance, which is A square root 3 divided by 2, equals to this P by 2 moment. So P by 2 times this horizontal gap here, which is equals to A based on the geometry given. So A is cancelling here, so your FBD value comes out as P divided by square root 3. So I can substitute these values in these equations. So your F1 value based on this, FBD cos 30 with a minus sign, so minus P by square root 3, and cos 60 is going to be half, so that's the first term, and the second term is again minus P by 2 sin 60, which is square root 3 divided by 2. From here we can find the value of F1, which is minus square root 3 by 4 coming from the second term, and minus 1 over 2 square root 3 coming from the second term times P. So that's the value of your axial force that we have. Similarly, we can calculate the value of V1 from this. So if I substitute value of BD here, I get minus P over square root 3. Sine 60 is square root 3 by 2 plus P by 2. Cos 60 is half. So this gives us a value of V1 equals to minus P by 4. The MB1 value is already here, so we can write MB1, which is equals to PA divided by 4. So to mark all of this on a section, I can draw section 1 separately here. So this is where your FBD is going, and this is somewhere your section 1 is there. So on this one we have the axial force, the shear force, and a bending moment. So value for these, if I simplify this, I get minus 0.72 P. The shear force is minus 0.25 P coming from here, and a bending moment is again 0.25 P. So this is how your section 1 looks. Now if I want to analyze section 2 is this one right here, so I can isolate this part. This is much easier for us to analyze. So if I draw the section 2 free body diagram separately, so I'm going to have this structure in this manner. I can draw the unknowns. I have this axial force, this shear force, and this bending moment. Call this F2, V2, MB2, and at the bottom we have this reaction, which is P by 2, and we have already seen that this can be divided into two components. So this one is your P by 2 cos 60, and this one is P by 2 sin 60. So once I divide this in components, I can completely remove this force from here. And now in terms of distances, this distance from here to here is A by 2. So we can do the force balance on this. So you can see your F2 value is going to balance this one. So they are in the same sense. That's why minus P by 2 sin 60. So P by 2 sin 60 value is square root of 3 by 2. So your F2 is nothing but minus square root 3 by 4P. Your V2 value, V2 and P by 2 cos 60, they are in opposite sense. So V2 is directly, cos 60 is half. So P by 2 times half, P by 4. And your MB2 in this case remains same. If I take moment over this point, it's going to balance that force that we have removed from here, which was P by 2. So moment because of this P by 2 is going to be P by 2 times A by 2. So now we have all the values. If I draw a separate section here for section 2, the forces on this one right here are going to be your axial force, which is this one. So if I simplify, I get 0.433 P. Your shear force going this way, which is 0.25 P, and your bending moment here, which is again 0.25 times P. So this is your section. So we have drawn the internal force and moment for section 1 here and section 2 right here.